Okay, let's make sure we're working. We're working. All right, so hopefully we are ready for another lecture. So this time we are looking at measures of central tendency. Measures of central tendency. And the first thing that we need to do is define what a measure is. And a measure is any calculation performed on a set of data. So a measure is just another way to say calculation. I'm just going to check real quick, make sure we're centered on here so you're seeing the full board. Move that just a little bit. There we go. Okay. So anytime that you want to do a calculation, in statistics it's called a measure. And when it comes to measures, there are a bunch of different types of measures that we're going to learn, but some of them come from the population. So if you have a population, meaning you have all of the data, then when you brain fart, okay? If you have all of the data, when you do your calculation or your measure, you can be 100% sure of your answer. And sometimes we're looking at a sample, and if we look at a sample, then the calculation or the measure that we do is correct for that sample, but it's not 100% correct for the entire population. And we'll talk about that in a little while. Right now, it's just focusing on finding these guys, okay? But we say that a parameter is a measure from the population and a statistic is a measure from a sample. So we're going to have parameters and statistics. And the thing about them is that they will have different variables to keep them separate from each other. So you know when you're dealing with a parameter and you know when you're dealing with a statistic. Okay? Now, let's look at measures of central tendency. So measures of central tendency calculate the center of a data set. And there are 4 different measures of central tendency. They all start with M, so that might be helpful, it might not be helpful. But we have the mean, the median, the mode, and the mid-range. Okay, mean, median, mode, and mid-range. Right? So let's start by calculating the mean. I'm going to leave this board here for us to do our example on, so I'll come all the way over here. And we're going to say the mean, which is also called the arithmetic average, is the sum of all the data values divided by the total number of values. So the mean is the guy that we're used to hearing called the average, or the arithmetic average, but the average. The truth is that all four of these guys are averages. Average is just another way to say measures of central tendency. Okay, so measures of central tendency, this can also be called averages. So all four of those are averages, which means that when we hear in stats, because we're using all four of them, that we want to make sure that we use the proper name with the proper calculation. So if we're doing the mean, we're not calling it the average, we're calling it the mean. Now, there are going to be formulas here for the mean, and I say formulas because there's going to be two of them. We're going to have one for the population and one for the sample. So if we are dealing with a population, the variable that we use for the population mean is mu. And mu looks like a U with a tail on the front. And I'm not just being cutesy, that's what it looks like. So, mu. And it's the Greek letter M. And mu is equal to the sum of the x's divided by n. So if you haven't seen this before, this is the summation notation, and this just means to add everything up. So this is the sum of all of the data values. Add all of the data values and then divide by the total number of data values. So add everything up and divide by the total number. Now, if we're dealing with a sample, the variable that we use for sample mean is x with a bar across the top. Okay, and we just say that x bar. Okay, so this guy is x bar. And the nice thing about x bar is it has exactly the same formula. It's the sum of all of the x's over n. So the formula doesn't change from one to the other, but the variable does. So if we're dealing with a population, we use mu, and if we're dealing with a sample, we use x bar. Okay, so let's get a number of numbers on the board here and do some calculations. So here is our example. And we're gonna say that our example is a population. And we've got 6, 3, 4, 27, 6, 4, 3, 2, 7, 4, 1, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Okay, I got them all. All right, so let's say that we were asked to find the mean. Now, because we're looking at a population, if we're finding the mean, it means that we're using mu. So we're gonna say mu is equal to. And what I want you to notice is that every time we answer a question now, it's gonna be attached to the variable. So every time we're going to say, like mu equals, never are we gonna just have a number just circled in the middle of a paper. It's always gonna be attached to a variable to get full credit on this. Okay, so we need to add up all of those numbers. So take a minute to add up all those numbers. And if you do, hopefully you get 73. And we're gonna divide by the 12 numbers that are up there. And if we take 73 and we divide it by 12, we get 6.1. All right, now, when we do a calculation and a number pops out that is not perfect and has a decimal, we have to carry that decimal. Do not round this to 6. Okay, if you round this to 6, you're not gonna get credit for that. So we need to round to one more decimal than the data. So our numbers were whole numbers, so we round to 1 decimal. If our numbers had decimals in them, just 1 decimal place, we would round to 2 decimal places. So we always want to round out more than our data comes to us with. Okay, so always rounding a little bit more. All right. Okay, so we've got mu equals 6.1. So we found the mean. Not too hard, right? So then let's learn the next guy. So remember, we've got mean, median, mode, and mid-range. So the next guy will be the median. And the median which always gets a capital M. Whether we're looking at a population or a sample, median is always a capital M. And the median is the middle value when the data is in order. Okay, so the middle value when the data is in order. No formula for this one, we're just putting our numbers in order and we're finding the middle value. So with that being said, normally your numbers are not going to be in order. So the first thing that you need to do when you're finding the median is make sure everything is in order. So if the next thing here said to find the median, then we would say M is equal to, and we need to get them in order. So if we put them in order, I'm going to put it right underneath here. So we've got 1, 2, 3, 3, 4, 4, 4, 6, 6, 6, 7, 27. All right, so we get them in order, and then we have 12 numbers up there, so we're going to go 6 in each direction. So if we go in 1, 2, 3, 4, 5, 6, and we come in 6 that way, we'll be right in between the 4 and the 4. So what we need to know is what number falls in between 4 and 4, and that's just going to be still 4. And if ever you're doing this and you can't quite tell what number falls in the middle, like let's say the numbers are decimals or just really ugly numbers, you can always take the 2 on either side. So we take 4 plus 4, add them together, and divide by 2. So 4 plus 4 is 8, divided by 2 gives us 4. So take the 2 numbers to each side to get us that middle number. Okay? And if you have an odd number of numbers, then the middle number is just the number that's in the middle, and that's easy to do. But in this case, we have to find our middle number. Okay, now these are both measures of central tendency, or averages, but measures of central tendency. But notice how they're not the same. So we've got 2 values that are not the same, and we need to know why they're not the same. So what we want to do is think about this for a minute. And we want to think about the fact that when we find the mean, we're adding up all of the numbers, right? All of the numbers. Which means we added up this 27, didn't we? And that 27 is in that 73, which means when we divide by 12, we get this 6.1, right? But that 27 is not really all that important when it comes to this number here. Now think about this. If this had been a 7, maybe it was meant to be a 7, okay, but we mishit 2 numbers and it was supposed to be a 7. Now if this was a 7, is this number going to change? And it is, it's going to change a lot. So that number is going to change, so that number is going to change. But if this number is a 7, does this number change? Or does it stay at 4? Right? And it stays at 4 because when you're looking at the median, you're only really interested in what's happening right at the middle. So the median doesn't really care about any high or low values that you might have, where the mean takes on every single value. So we tend to say that the mean is more volatile than the median. Helps if you actually spell the word right. Volatile, there we go. Oh my God, talk about a brain fart. Okay, so the mean is more volatile than the median. And that means that the mean gets worked up more. The mean is more changeable. And because of that, we can learn something just by knowing the mean and the median. So we can look at the mean and the median, and it can tell us the shape of the graph. So in our situation, if we were to look at the shape of our graph, we have a graph that has a mound on one side and then it has an extremely long tail. All of our values are around 3 to 6 and 7. So we're all in a very small area, and then we have this crazy 27. So we've got all of our values here and then a crazy number way out here. So our graph, and I'm not going to draw the bars in there, but just if we were to draw the bars and sketch a curve of the graph, would look like this. So thinking from the last lecture, we are definitely skewed to the right on this one, so we're skewed right. And when we're skewed right, we see something interesting happen. The median is going to stay near the middle of the bump. So the median stays near the middle of the bump, but the mean is going to be pulled towards the tail. It's going to be pulled towards the skew. So our mean is going to be out to the right-hand side. So because our mean is bigger than our median, we know that we have a right skewed graph, okay? And if it had been the situation where we had a left skewed graph, the median is still going to stay near the middle, okay? But again, the mean is going to get pulled towards that tail. So this time the tail is going to the left, so the mean is going to go out to the left. And if we were to find that both the mean and the median were the same, if we were to find that they were both the same, that would tell us that we have, that's a pretty crappy bell-shaped curve, but go with it. That would tell us that we had a bell-shaped curve. So if the median and the mean are the same, then we are bell-shaped. So you don't need to know anything about the numbers, anything about the original numbers. If you have the mean and the median, you know what the graph looks like, okay, with just the mean and the median. All right, so we said that the mean is higher because of this 27 value. We don't get to just get rid of him. We have to keep him because he's there. He might be a mistake, but he's there, so we'll use him. All right, and then we're moving on to the next one. So we've done the mean and the median, and now we've got the mode. And the mode is the value that occurs most often. Okay. There can be one mode, two modes, three modes, no mode. So the mode is not necessarily the most helpful guy, okay? Because sometimes there's a mode, sometimes there's not even a mode. But what we're looking for is the guy that occurs most often. So over here, if we were being asked to find the mode, we're gonna find the mode. Now, unfortunately, the mode doesn't get any variable at all. I don't know why, but he doesn't. So we would just have to say mode equals. So we have to write out the word mode, which is kind of annoying, but we can do it. Okay. So in order to find the mode, we're looking for the guy that occurs most often. And when we look up here, we see that 4 occurs quite a bit. But so does 6, doesn't it? So there's 3 4s and there's 3 6s. So we actually have 2 modes. So we're going to say 4 and then comma 6. So there's actually 2 modes going on, which not super helpful. Okay. Whenever you have 2 answers, I guess you can use both of them. You can use one, you can use the other. Yeah, so the mode is not always super helpful. So why do we even deal with the mode? Well, if it's not super helpful, if there could be no mode or 1 mode or 2 modes or 3 modes, why do we deal with it? And we deal with it because it does have one good characteristic, okay? The mode is the measure of central tendency used for qualitative data. Okay, so what we're talking about here so far is numerical data. We're looking at quantitative data. But what happens if we're talking about qualitative data? So we're talking about things that can be arranged into categories, not numbers. So we need a measure of central tendency there as well, and that's where the mode comes into play. So we may hear something like the average hair color is brown. Well, how do you add up hairs and divide by the total number of hairs? I don't get that. How does that work? You can't, because these guys are categories. So what does it mean for the average hair color to be brown, it means that there are more brown-haired people than any other color. So the mode is brown hair. So there's more brown-haired people than any other. So the mode. And that's why we use the mode for these qualitative variables and qualitative data that we've got going on. But for us, when we're dealing with numbers, sometimes it's helpful, sometimes it's not. So again, while the mode can be helpful, we still want to rely more on these two numbers. Okay, these two numbers to get us through. Now, the last guy we've got is the mid-range. And we're going to talk about the mid-range for a couple minutes, and then we're going to be done with it. The mid-range has become obsolete, and we don't use the mid-range anymore. But let's give it its like 5 minutes of fame, and then we'll be done with it. So we say the mid-range which gets the abbreviation MR, is a quick measure of the sum of the high and low values divided by 2. So the formula looks like high plus low divided by 2. So MR equals high plus low divided by 2. Okay. So let's look at finding the mid-range here. You would say the MR is equal to 27 plus 1 divided by 2. So 28 divided by 2 is 14. Now remember, this is supposed to be a measure of central tendency. It's supposed to be telling us where the center of our data is. So the center of our data is in this region here. So 3, 4, 6, center. Okay. Does 14 represent our data very well? Okay. It doesn't represent our data really all that well at all. Okay. And because of that, this is why the mid-range is not helpful and actually is obsolete. What it used to be is that you may have been given a bunch of numbers and you needed to find a real quick measure of central tendency. So it's really quick to go and to find the low and the high number and add them together and divide by 2 and say, well, the mid-range is 14, the measure of central tendency is 14. But it can be very off depending on if you have that high value, that weirdo value that we have. If you do, this number doesn't represent your set of data at all. It's very off, okay? It's very skewed. So it's better to rely on the mean and the median. And now that we have computers and calculators, it doesn't take us that long to find the mean or the median. You can find them very quickly. Even if you have a whole bunch of numbers, let's say you were given 1,000 numbers, you can cut and paste that into StatCrunch and end up with the answer really quick. And so you don't need to rely on doing this by hand or adding up all the numbers, because I wouldn't want to add up 1,000 numbers. If someone that said add up these 1,000 numbers, and I said, well, I can give you a real quick answer by finding the mid-range, then I would go with the mid-range because I'm lazy, okay? But these guys are definitely more reliable. So with the invention of the computer programs that we have now, the mid-range has become obsolete. So we'll say goodbye to the mid-range. So the ones we're gonna focus on then are the mean, the median, and the mode. Mean, median, and mode. Okay. I don't even think your book mentions the mid-range. Poor old mid-range. All right. So those are your measures of central tendency. You will use them on a daily basis, so get very comfortable with them. All right. Okay, I'll see you for the next one.